Guys, here is a quick solution for the problem in homework number 8, 2516. And in this problem here, we are given 100 Turing coils with the radius 12 centimeters and with the magnetic field 0.15 Tesla. And the coil is rotated by 90 degrees, and the time that rotates in that one, it is just 0.3 seconds, and ending up to the parallel to the field. What is the average of the induced EMF coil as it's rotating? So basically what we have new here, the only thing if you look at your textbook, we find the formula when you have the number of the Turing in my coil. So just the EMF, as we mentioned, it is just absolute value of delta phi divided by delta t. So when I have internal, in this case, the only change in my formula, E will be N times every wire it has flux. So end up with the just typing N number of the Turing divided by delta phi and delta t. Once you have this formula here, you can just extend it to this part. So we have N, and here's the times delta phi. We know delta phi means phi f minus phi I. Phi f minus flux, initial flux before we rotate, divided by delta t. That's the time that I have. So now regarding for the phi I and phi f, here is the formula. We have A times B times cosine theta. It's called theta f. And phi initials, A times B times cosine, this called cosine theta I. So I have A and B, they are the same. Area and magnetic field, they are the same. So the only thing I need to figure it out, what's my theta F and theta I. So theta, if you just quick reminder, is the angle between the center axis for the wire. So in this case, it will be this one here. This is the center axis. And the magnetic field. So here, theta I will be 0. Now the second situation, when I rotate it to the 90 degree, which means is my magnetic field with the wires, they will be the same one. So in that case, the theta F, it will be 90 degree. Imagine if you just rotate this wire here and the direction is the same direction of magnetic field, write down the axis, you will find the theta will be 90 degree. This is the center axis. So now we know the theta I and theta F. So I have A and B. So now I can write down my equation in that way. So here is the N times my phi. I will write it down. A and B, they are the same. So I can take it outside. A times B, the same magnetic field, the same area. So the only difference now here is the cosine theta F minus cosine theta I divided by delta t, and take the absolute value this case. Now let's plug the number in our formula. Here's how I have 100 Turing times absolute value. I have A, it will be by R squared, pi times 0.12 meter square times 0.115 Tesla. And this one times cosine 90 degree minus cosine 0 degree. And the entire values here divided by 0.3 seconds. So here is the cosine 90, 0. Cosine 0 will be 1. Here's the minus 1. Absolute value will be in up with the positive value. So the value according for this calculations will be 0.2 something. Just confirm this number, guys. I think 0.12 volt. So you calculate this one. Just I wanted to make the video short, so you can just calculate it and make sure it fit with the number. Okay. Thank you so much, guys.